Hi, my name is Salmantur. I worked at Scaleout Systems, and as most of you knows that Scaleout System focusing on providing highly scalable platform for federated machine learning. The name of our platform is Fedn. And in next couple of minutes, I will show you one of the core feature of our platform, that is how we enable resilience and fault tolerance in the system. So, but first quickly, let's have a look at what is federated machine learning in a classical manner. So I guess most of you are very familiar with the kind of settings that we have in this picture. There are different nodes. Nodes are not allowed to share the data, or the data is too big to be shared. But then there is a possibility of having, based on this aggregator node, that you can still work and generate a highly accurate model. And there are different options available how you train the model. But in the end of the day, together with providing an accurate model, there are other challenges as well when it comes to the federated machine learning. What if one of the nodes is not available? Or what if the network connectivity between the nodes is not stable? Or in some cases, what if the aggregator node is not available for some time? How normally things can be handled in this kind of federated training environment when the training is on? So all these are the challenges that are equally important when it comes to the federated machine learning, where the main focus is to have highly accurate machine learning models. At Scaleout, we have developed Fedn. It's an open source platform, highly scalable, and it works for both cross-silo and cross-device kind of environments. Everything is available on GitHub. You can go download the repo and get started. Documentations are available there. So when it comes to the architecture compared to the classical architecture here, what we have done is that we have built a three-tier kind of environment, where on the first tier we have clients that first connect to the combiners in the tier 2, and the combiners are further connected to the reducers, and then we have a network based on active and passive, or master and or the backup kind of reducers. So based on this hierarchical architecture that is inspired by the MapReduce kind of approach, we provide resilience and fault tolerance in the system. And other services, as you know, that when it comes to the highly scalable distributed environments, you need to have some base services. So those services work as a backend to the system. What is outwards visible is reducer and the combiners. So let's have a quick live demo and see how Fedn handles the crashes that may happen in the during the training process, or while the system is just connected without having any training process ongoing. So I will show you a live demo here. You can see that we have a dashboard based on Fedn. I will not go into the details of how Fedn looks like and what kind of options are available. There will be a link available of another demo in the text, and there you can find more details about Fedn. So first of all, I can show you the network connectivity at this point. So here you can see that we have one reducer, we have two combiners, combiner east and combiner north, and there are 4 clients, 2 connected to the to combiner east, and the other 2 are connected to the north combiner. So based on that kind of environment, I have already trained a basic machine learning model, and if I click on the dashboard, you can see that I can click on the training loss. You can see that in different rounds are basically when when the alliance admin or the alliance admin tells all the client that, okay, now it's time for you to start the training process. So far I have already run 6 rounds in the system. Here is the status. So let's go and in this static settings, when we have this network available, let's go and kill our reducer and see what happened, because reducer is the one that does all the aggregation and responsible for everything. So what happened if we just simply kill our one of the reducers? Seems like this reducer is active, right? So let's kill this one and see what we can see on the network side. Maybe this one was like a bit quick. Yes, now we can see that network, the system is not available. Let's see. Oh, it's back again, and with all the information. This shows that if you have some issues on the reducer or the aggregator side, things can recover because we have multiple components running in the system. So let's start the first reducer again, and the one that is now active, let's kill this one, because at least we need one of the reducer to be available. So that was active at that time. Now we have killed this one. Let's see what happened here. Seems like system is working fine. So this shows that, okay, if combiner or reducers, I will show you the combiners as well, but this shows that if even the core component in our system, that is the reducer, have the aggregation task, if that dies, still the system is available. But that is more like a static settings, right? I mean, the training was not going on. So what happened if the training is ongoing, and then reducer have a task to do the aggregation, and if I kill my reducer at that time, how the system cope up with those kind of challenges. So let's go to the controller tab and start, let's say 20 rounds, and see how the system handles that crash, if we manage to do that. So now we have started the training process. Soon we will see. Let's go and see how the system is behaving right now. We still have 6 rounds available. Let's go to the network and see if everything is available. Just seems like things are running fine. Let's go to the dashboard and see if we have more. Yeah, now we have 6 and 7. More rounds are coming to the system. Right. We can wait for one more. Yeah, now we have 8 rounds. So let's go and kill the reducer that's doing the work. So here it seems like this reducer is off. We can start this reducer, right? And this reducer is up now, but this is the one that's doing all the work, right? So let's kill the reducer and see what happened in the system. So let's kill this one. And see how the system looks like at this stage. Oh, now it shows that system is off, but in the next click, when I refresh the page, system is back again. Let's go to the dashboard and see what is the status here. So here you can see that we have managed to handle the rounds that were running before the crash happened. So let's see if there is more information or not. It seems like the last round that, before the crash was round number 11. So what happened in the system internally is that the system tried to serialize all the information that happened just before the crash, and it just stops the training process when the crash happened. This is mainly because if we continue that kind of training process while the crashes are happening, there is a high chance that we will lose the important information. So what system has shown us so far is that whatever we have done before the crash happened, everything is nicely saved in the system. We don't see any glitches or any jumps in the training process. It is going smooth. However, we couldn't manage to complete all the rounds. Remember, I have started 20 rounds, but we only have 11 rounds here, and the system is stopped. What we can do now, we can just simply go to the control round again, and let's say start 11 more rounds. And let's see if the system can handle that kind of crash and start the rounds again or not. Yes, new rounds are coming again. Now we have 12. Let's see if we can have 2 more rounds, so we will be sure that things are working fine. Yes, now we have now more rounds are coming. So whatever happened at the time of crash, system nicely handle all, nicely store all the information that was before that crash, and after that crash, there is no problem in the system. You can still start new rounds and continue the training process, and you can see the very clean and clear progression in terms of models that is generated in different rounds. And here you can see all different kind of options, and everything is nicely seen. So if we go to the network side, the status is same. Things are running fine, no issues at all. So yeah, things are moving fine, and we can again kill the reducer and try that, but I think that's that will be extra. So that's what I would like to show right now with the resilience side. So if you have more questions or anything that you want to discuss with us, please feel free to contact me or the team. More information is available on our website. There is an article available as well that explains more details about the architecture and different features in the Fedn. And also, if you are interested to have a demo for your organization, we are happy to organize that as well. So yeah, feel free to contact us and stay tuned, because soon we will announce more interesting features that we have recently enabled in Fedn environment. So bye for now.